So Tukey, what he did was he said, okay, we want to really quantitatively define what does it mean for an outlier. So he defined what is called the lower fence or lower bound. Sometimes it's called a fence. And the upper bound. Also upper fence if you want. Okay. And what he did was he said, okay, so if we have a data point that's less than Q1 minus 1.5 times the IQR, we're going to call that an outlier. Let me make the box a little bigger here. Yeah, so if there's anything below whatever value you get when you do Q1 minus 1.5 times the IQR, that's considered an outlier on the low side. For the upper side, he said, let's take Q3 and add 1.5 times the IQR. And that will be our upper boundary for an outlier. So anything that's bigger than that number is considered an outlier. Okay, so the funny story about Tukey is these equations have been around for a long time. He was one of the early mathematicians, and Tukey's method for looking at outliers has been around since early on in statistics, but nobody knew why it was 1.5 times IQR, and he wouldn't say. But Tukey actually, he actually died not too long ago. Yeah, he passed away in year 2000. So okay, so 20 years ago. It's recent for me. I'm old. All right, I get it. The thing is, he posited these equations, in the 1940s, and he would never say why it was 1.5 IQR. And finally, on his deathbed, and when he was passing away, he didn't have much long time to live. They asked him, like, okay, what is it? Why is it 1.5 times IQR? And he said, okay, I'll tell you. He said, because 1 seemed like too few and 2 seemed like too many. Go figure. But everybody uses his equations to this day. So I find it to be kind of humorous. So if we come back to our data set, okay, maybe I'm the only one. That's all right. When we come back to our data set here for the commute times in North Carolina, my lower bound for my outliers then, take that Q1, which is 10, and subtract 1.5 times the IQR. Well, remember, that was 20. Well, 1.5 times 20, okay, that's 30. So 10 minus 30 is negative 20. Well, nobody has a commute time below 0. So yeah, there's no low outliers. But for an upper outlier, right? If you take 30 plus 1.5 times that IQR of 20, what do you get? We get 60. Almost, right? We don't have anything that's above 60. We have one right at 60, but that would not be an outlier based on Tukey's equations right here. So yeah, 30 plus 30 would be 60. So no outliers in this data set. But that would be exactly how we would go about finding outliers if we had them in our data set. If I go back to commute times in New York. All right. Oh, sorry, I've got to swap the screen share over to there. All right. And remember, we found our median was 22.5. Okay, in here. So median 22.5 from these two guys. Q1 is 15. Q3 is 45. So we have an IQR of 30. Okay, so 1.5 times 30 is 45. So do we have any outliers of this one? No, our lower bound is 15 minus 45. Okay, so negative 30. The upper bound, oops, is 45 plus 45 or 90. So we had no outliers in this data set either. So there you go. Those are Tukey's equations. Interesting story about how they came to be, and the fact that it's just kind of feels really arbitrary is kind of weird because everybody uses Tukey's equations for finding outliers in a single variable data set. So, all right, guys, that's it for today. So you should now have measures of center, mean, median, and mode. You should know which ones are resistant and which ones aren't. How to describe spread in your data set. With IQR and most importantly with standard deviation. And finally, now we can formally define what it means to have an outlier based on Tukey's equation. So thanks for watching, guys. Have a great day, and I'll see you in class.